Hello, Algebra 1. We are at our last set of notes for the year. Yay. Today we are talking about the applications for quadratic equations. So those are kind of one of the most important parts of this unit, though we have scaffolded it and scaled it down a little bit just to kind of help us focus on the main key things we want to pull out of looking at real-world applications for these problems. So today's essential question says, what types of real-world situations are modeled by quadratic relationships, right? There's lots of real-world situations that we can use quadratics to model. So in general, the motion of an object as it is thrown and then falls back to Earth under the force of gravity can be said to follow the path of a parabola. One common equation that can be used to model this behavior is negative 16t squared plus v sub 0t plus h sub 0. Right, so this is like a general velocity equation that we would use when we're talking about airplanes taking off or space shuttles taking off or throwing a rock into the air, right? It has to do with how hard you throw and then the pull of gravity from Earth on that item to bring it back down to Earth. So H in this problem here, I kind of gave us what these key things stand for. All right, so H in this problem stands for the height. So HE is the height of the object being thrown. And this H, sometimes we'll see it H sub T, right? Or really this could be F of X, or this H could just be Y. It is really our Y value in our quadratic. So the H equals, that's the Y. If we're thinking about it in X and Y terms, if we were thinking about it in function terms, often you'll see it written as H sub T, where H is the height, and then T over here stands for the time. And T is our X variable, right? So the H is our Y variable, T is our X. And if you remember from when you're doing the linear stuff, right, time is always our independent variable, always on our x-axis when we're doing problems. V sub 0 stands for the velocity. So this is a number we would give you in the problem. So we would tell you what the velocity is, how fast the object's moving. And then H sub 0 stands for the initial height. Initial height. And if, so let me finish writing this, initial height. And if you remember back when we did y equals mx plus b type of linear equations, right? That initial height is always the y-intercept. Our starting value is the y-intercept. It's also, when you think about the ax squared plus bx plus c, it's also the c value, right? In ax squared plus bx plus c. So these are the key things that we're going to make sure we understand and know for these word problems. All right, so let's take a look at number 1 here. So it says a rock is thrown straight up from the ground at a velocity of 80 feet per second. The formula H equals negative 10t squared plus 80t gives the rock's height in feet after t seconds. A graph is provided for this first example. So for this first example, we're going to use the graph. If you're given a graph, provided a graph, use the graph to answer the questions. These are going to be 3 things that we're going to identify for all of these quadratic application problems. So we're going to start by identifying the vertex, the x-intercepts, which could be 1 or 2, and then the y-intercept, which is always just 1. So let's take a look here. So the vertex, remember, is the highest or lowest point. So all these problems we're throwing up into the air and it's coming back down, the vertex is always going to be a max value because it's going up and coming down. So the vertex for this problem up here is, and this scale is by ones, right? Because you can see the 8 here is on here on the scale. So if you want to fill those in, you can fill those in. But we are over 4 up 160. So the vertex is 4, 160. The x-intercepts, I'll make those purple. Here, we have an x-intercept here across the x-axis, and we have an x-intercept here across the x-axis. So the x-intercepts, one of them is the origin, 0, 0, and the other one is 8, 0. Right? We're just look at the graph. There's always two x-intercepts. Always look for them both, right? There's two places that this could occur. And then the y-intercept is again back at the origin. Anytime the x-intercept is the origin, that's also the y-intercept, right? So those are our points. So these 4 points are what we're going to use to answer questions about this quadratic equation. There are other questions we could ask, but for this year, we're going to stick to these particular questions. All right, so once we've identified the 3 to 4 points above, we are going to use those to answer the questions. So first question we're going to answer is, when is the rock at maximum height? Right, so if we're looking for the when is going to be time, right? So we're going to be looking for time. The maximum height is its height right here, right? We're going to find the maximum height, let's erase that and try that again, at the vertex. Right, so whenever we're thinking about how high the rock is being thrown, then we're looking for the vertex. So we want time. Time is right here on my x-axis. So we want the x-coordinate of the vertex. That's what we are looking for to answer this question. So if we look back at our vertex, right, our vertex was 4, 160. So that means the answer to this question is here at 4, right? So the answer is going to be 4 seconds. Now, you don't need to necessarily write it in a sentence, but make sure you don't forget the units, right? So don't forget units. It's a word problem. Word problems always need to have units on their answers. So the when it's at maximum height is the x-coordinate of the vertex. Maximum height is the vertex. The y-coordinate of the vertex is going to be the what, right? So here we are. The what is the maximum height is going to be the y-coordinate of the vertex. So y-coordinate of vertex is going to be the what is the maximum height, because height was the y-axis. So again, my vertex, if I look over here, right over here to the left, right, so 160 is the y-coordinate. That means that it's going to reach maximum height at 160 feet, because it measured in feet. All right, so maximum height tells us you have a time it's going to get there, and then how high it actually gets. All right, then down to the next problem. It says, what is the starting height? Starting height here, right? That's our y-intercept. Starting height is always our y-intercept. And we want the x-coordinate of that y-intercept, right? Because the y-coordinate of that y-intercept is 0. So we're looking for the x-coordinate of the y-intercept. So if the y-intercept here is 0, 0, then that means for this problem, because we're at the origin, we're starting on the ground, this is 0 feet. So sometimes we will launch things off the ground, some things we will launch things off of a ladder or off of a building or off of something that has some distance from the ground, right? But this height from the ground is 0. So this, what is the starting height? Looking for the y-intercept. For this problem, it's 0 feet. And then D, when did the rock land back on the ground? Back on the ground, so we started on the ground, and then we had to go back on the ground. Back on the ground is going to be the, what we're looking for here is, right, when y equals 0, x equals question mark, right? It's the x-intercept. We're looking for the second x-intercept in this problem. So the second x-intercept is 8, 0, which means that in 8 seconds, we're going to be back at a height of 0, right? Because we're back on the ground at 0 is 0, feet off the ground, right? We're back on the ground when y is 0. That's why we set the y equal to 0 here, because the ground is 0. Okay, so those are the 4 key things we are going to be identifying on these quadratic problems. So sometimes we'll be given a graph to provide this identification. Sometimes we'll be given the equation only, and then we'll have to figure out these 3 things here. We'll have to figure out from just the equation. So let's go ahead and do that next. So let me go to the next page. All right, so the height in feet of a football that is kicked can be modeled by the function h equals negative 16t squared plus 64t when t is time in seconds after it is kicked. And then I put a hint here. I said the fastest way to find intercepts is to factor. This is the x-intercept. Might want to put the x in there. See, do I have a black here? Might want to put the x-intercept there, because we use factoring or quadratic formula or square roots to find those x-intercepts. All right, so I gave you kind of a hint. I told you the fastest way to find it is to factor. So we're gonna start with the vertex. Vertex we don't need to worry about factoring at all. All right, vertex, if you remember, back when we were doing vertex, is negative b over 2a for the x-coordinate of the vertex, right? So let's identify your ABCs. So my A is negative 16. I'm gonna make this a little bigger over here so I can write a little easier. B equals 64 and C equals 0. There's no C. So to find the vertex, I'm going to do negative 64, because that's my B, divided by 2 times negative 16, which is negative 64 over negative 32, which equals 2. So we're looking for a point. The x-coordinate of that point is 2. And remember, x is time, y is going to be height. So we have 2 seconds, because this is seconds, right? So let's look. Seconds, yeah, t is time in seconds. So this means in 2 seconds, we're going to be at the vertex, at the maximum height. And then we're going to find the y-coordinate, right? So then we have h equals negative 16 times 2 squared plus 64 times 2, right? Plugging in and solving. So then we have negative 16 times 4 plus 64 times 2. If we just do that first part, which is negative 64 plus 128. Doing the math quickly. So then h equals 64. So there's my vertex, 2, 64. 64 feet high in 2 seconds. And it's the vertex, so that means it is the maximum height. Okay? All right, now we found vertex. Let's go over and find x-intercepts. All right, so x-intercepts, oh, there is an x up there. Just didn't make it down. X-intercepts says, I said to factor, right? So let's take our problem. We're going to set the y equal to 0, which is our h in this case. So we have 0 equals negative 16t squared plus 64t. And there is no c value, so we definitely can divide out a t. We could also divide out, actually, a whole negative 16t. You could start taking out what you see and then just keep going. You could check. I always check to see if 16 goes into the second number, because if it does, that's the best one to check. But so what this equals is 0 equals negative 16t times t minus 4. 64 divided by negative 16 is negative 4. Right, and then we're going to go and we're going to solve. Right, so we're going to do our 2 things here. So we have negative 16t equals 0. Divide both sides by negative 16. T equals 0. And then we have t minus 4 equals 0. Add 4 to both sides. t equals 4. So my x-intercepts are the origin and 4, 0, right? Because t is my x. We're looking for when y is 0. So those are my x-intercepts for this modeling. Okay, and then we said I want you to find the y-intercept. Now we haven't done the y-intercepts yet really this year, but if you remember, to find any y-intercept, we make x 0 and solve for y. So here's my equation. H equals negative 16t squared plus 64t. So we're going to make the x equals 0, which in this case means the t equals 0, right? Same thing in this problem. So I want to know the height when t equals 0. So negative 16 times 0 squared plus 64 times 0, which is just negative 16 times 0 plus that's already 0, and that's 0. So that's 0. 0 plus 0, 0. Kind of already knew this was the y-intercept because anytime the x-intercept is the origin, then that's also the y-intercept because when x is 0, y is 0. So there's my y-intercept, 0, 0. All right, so now that we've found the vertex, the x-intercepts, and the y-intercept, we can answer the 4 questions below. All right, so number A, or letter A, says, when is the football at its maximum height? All right, so again, remember, the when at maximum height is the x-coordinate of the vertex. Right, so when we're at our maximum height is vertex, it's the x-coordinate. So if I go back to my vertex was 2, 64. So that means the answer here is 2 seconds. There we go. And then B says, what is the maximum height? So maximum height is the vertex. That is how high do we go? We went. And so this is the y coordinate, just to remind us, because there are notes. You don't have to write this when you're doing your homework, but just to remind us in our notes here, y coordinate of the vertex means that we're at 64 feet. Because I already wrote down the vertex at 264. So at 2 seconds, we're at our peak, and that's 64 feet at that peak. What was the starting height? Again, this is the y-intercept. Right, so the y-intercept tells us the height, the y coordinate of the y-intercept. This is 0 feet. Anytime we're at the origin, the height is 0. We're on the ground. And then when did the ball land back on the ground? Right, that's the second x-intercept when we're back on the ground. So our we had 0, 0, and we had 4, 0. Put commas, right? So 4 is our answer. So this is 4 seconds. There we go. So by finding the vertex, the x-intercepts, and the y-intercept, we can answer questions about maximum height, and we can answer questions about starting height, and we can answer questions about when it comes back to the ground. All right, one last problem that we'll do together. All right, so a child throws a ball upward with an initial velocity of 14 feet per second from a height of 3 feet. The formula that models this is h equals negative 16t squared plus 14t plus 3. This one, to find the x-intercepts, we're going to have to use the quadratic formula to make this work. This one's not factorable. And whenever we're solving quadratic formula in these word problems, we're going to have to use a calculator and get estimations for those radicals. So if you don't have a calculator handy, but if you have a calculator somewhere and you don't have it handy now, you might want to pause and go grab it so you can follow along. But you are going to have to use a calculator for these problems that require radicals. So let's start with the vertex, though. We don't need a calculator for the vertex. Well, maybe we do. I don't remember this problem. So vertex, again, vertex, negative b over 2a, always. So I'm going to identify, I'm going to go ahead and make this a little bit bigger so I can have room. Right, so my a equals negative 16, my b equals 14, oops, my c equals 3. So there's my a, b, and c. So my negative b over 2a is my negative 14 over 2 times negative 16, which means this is 14 over 32, which simplifies to 7 over 16. Now, since we are going to be answering questions about time and height, then you should go ahead and find a decimal equivalent rounded to the nearest hundredth. So round. So whenever we're doing these problems, when we were doing the solving quadratic formulas, we asked you just to keep it in radical form. When we're doing these word problems, we want to go ahead and make it decimals and round to the nearest hundredth. So 7 divided by 16 is 0.44, right? So if I'm looking for my vertex, I have 0.44. There's my time. And then we're going to plug into the equation, and this is where having a calculator is super helpful. It's negative 16 times 0.44 squared plus 14 times 0.44 plus 3. All right, so if you did some of the math, you could plug it all in your calculator and just come up with an answer. That would be fine. I have negative 16 times 0.19, 0.44 squared simplifies to 0.19 plus the 14 times 0.44 plus 3. And then if we multiply that across, I have negative 3.10 plus 16.16 plus 3 if we keep rounding to the nearest hundredth. If you plug it all into your calculator and don't round, you might come up with a slightly different number. As long as it's close, you'll get credit. That is fine. If your rounding error is just off a little bit from mine, that is totally fine. Right? So then we go ahead and we add all of those numbers together. Just checking. Equals 6.06. Right? So my height is 6.06. 6.06. That is kind of squishy over here. I'll box it in red here, right? So my vertex is 0.44 and my height is 6.06. Right, so you're going to have to go ahead and use calculator, plug in, that's fine. Round to the nearest hundredth as you go. If you put the whole thing in your calculator, you may have 6.07. If you have 6.07, that's fine too. It's probably a better answer than 6.06. But at a minimum, you need to go to the 100th place before you start rounding. So if you round at the 10th place, your number is going to be way different than my numbers, potentially, depending on the numbers. All right, now let's find x-intercepts. Now I said you had to use the quadratic formula for x-intercepts here, right? So I'm going to write down my ABCs again. Let's go ahead and make this back to, let's make it purple. So I have A equals negative 16, B equals 14, and C equals 3. After you write these down, check to make sure you don't have a GCF. You should have divided out. Because remember, if there's a GCF that can come out, it'll make the math much easier if you take that GCF out first. But there isn't, so we're good. So now we're just going to plug into our equation. X equals negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So that's plugging in negative 14 plus or minus the square root of 14 squared minus 4 times negative 16 times 3, all divided by 2 times negative 16. And then I'm going to do some simplifications here. So I have negative 14 plus or minus the square root of 196 plus 192, all divided by negative 32. Right? So I just did that math. I did the 14 squared, and then I did the negative 4 times the negative 16 times 3. And so that leaves me with negative 14 plus or minus the square root of 388 divided by negative 32. Now, if we're doing word problems, at this point, I wouldn't even worry about simplifying the radical expression because we're going to have to get a decimal equivalent anyways. So what I would do right now is I would take my calculator out and I would put into it negative 14 plus the square root of 388, and then I would divide it by negative 13. So I'd do those two things, right? So I'd say x equals negative 14 plus the square root of 388 divided by negative 32. And that becomes negative 0.17. So put it in your calculator, make sure you get the same answer I just got. Right? So that is my first value for x. And then you're going to do the second one. X equals negative 14 minus the square root of 388 divided by negative 32. And when you plug that into your calculator, you get 1.05. So here are my two answers. I have negative 0.17, comma 0, and 1.05, comma 0. Now, when you're thinking about x-intercepts in these problems, and this should kind of make some sense to you, right? If I was going to sketch out a little graph of this, right? We had a starting height up here at 3, right? And then we're coming back down, and then it was really fast. It was like 0.44, we're at our max height. And then we come back down and we are back on the ground a little over 1, right here. So this graph goes something like that. Just a little sketch. This value over here, right, has no bearing on this word problem because it's the other half of the parabola that doesn't make sense. Our maybe actually go up here a little bit, right? But we're starting here at 3. And so from 3, we're going to go up and then back down. We don't care about what's going on here on the left side of the y-axis because we start time at 0. So kind of like when we were doing those linear problems, right? We didn't care what was going on the left side. If we had an x-intercept that was not the origin, and it was going a positively increasing line, then it was, then there wasn't an x-intercept that was negative, we kind of just got to ignore. So anytime you get a negative x-intercept in these quadratics, we get to ignore those because time starts at 0. So we only are worried about things where the y-axis starts. So this is going to be the x-intercept that's going to give us when we're back down on the ground. Okay? All right, now let's do the y-intercept. Y-intercept should be a little bit easier, right? Because y-intercept, we take and we plug in 0 for x and solve for y. So I have h equals negative 16 times 0 squared plus 14 times 0 plus 3, right? So this equals 0 plus 0 plus 3, or just 3, right? And we said in the problem that she was standing at a height of 3 feet, right? So if we're standing at a height of 3 feet and throwing something in the air, then that means our starting height is 3. So when x equals 0, y equals 3. This value here, right, is your starting value, your c value. Just like in y equals mx plus b, that's your starting height, then it's the same principle here. Y-intercepts are super easy to find. Not always on the graph, but super easy to find. Plug in 0 for x, solve for y. It's always really super easy. Way easier than x-intercepts, because the x-intercepts, right, we had to do all that quadratic work over there. It can be kind of a pain in the butt sometimes. All right, so now let's answer the questions. When is the ball at its maximum height? Right, looking for maximum height. That means we're looking for the vertex. The vertex was 0.44. We're looking for the when of the vertex. That means at 0.44 seconds. The ball, was it a ball? It was a ball, right? The ball was at its maximum height. Maximum height, you should be automatically thinking vertex every time, right? Max height, max and min of a parabola, quadratic. So then what is the maximum height here? This one says, what is the maximum height? That maximum height is 6.06 feet. Right? So in 0.44 seconds, it's going to be at 6.06 feet. What is the starting height? So this down here, the starting height, again, is always the y-intercept. The y-intercept this time was 0,3. So that means that our starting height was 3 feet. There was a c value. So it did have a y-intercept. And then the last question says, when when did the ball fall back on the ground? So we're looking for that second x-intercept. That second x-intercept is 1.05 seconds. That's when the ball is back on the ground. All right, so there we are. Some word problems, some application problems. On your homework, I tried to tell you if you should solve by factoring or solve by quadratic formula. You can solve all of them by quadratic formula technically, but sometimes it's faster to factor. And it doesn't require, because there's no radical answer. So it might be easier for you. So it might benefit you to kind of take a look at that. And if it says it's faster to do by factoring, you might want to try by factoring, keep practicing those. And if it says faster by quadratic formula, many times radical answers, you have to do quadratic formula, and we need you to round to the nearest hundredth for those problems. Okay, so there we are. On Wednesday, we will go over some of these in class. So that way we'll do a couple more of these problems in class. Your homework is doing some of these problems. Your quiz this week, there's going to be 2 problems. There's going to be one problem with a graph that you're going to have to answer questions on the graph. And then there'll be one problem from an equation and that you'll have to answer questions from the equation. I believe that's what but it looked like a practice quiz. All right, awesome. Let me know if you have questions.